Suppose we have an object traveling in a straight line as shown. Now, as it's trying to move in a straight line, somebody pushes on it. So in comes a force, and maybe the force pushes sideways like this. Now, if somebody pushes sideways on the object like that, obviously it's not going to go straight. Instead, it would go, well, keep on going up, but it would also go to the left a bit. It would be coming along and maybe do something like this. But then what if, as it changed direction, somebody applied a force again? And again, same thing would happen, is it would change direction again, maybe something like this. And then somebody pushes again, and of course, it keeps on happening again and again. And you can probably see if this pattern keeps on continuing, the object would actually create more of a circular path as it was traveling. And this is the basic idea behind circular motion. Now notice that the forces are actually pointing to the middle of the circle. And a lot of people have the idea of when something goes in a circle, there's a force going out. But there isn't actually a force going out causing it to travel in a circle. Now the force going in, this is what's often called centripetal force. And centripetal force is a force that goes towards the center of the circle and causes objects to make a circular path. There's another term that comes up which is called centrifugal. Now, centrifugal is a force that's talked about as being a force trying to pull you out or push you out from the middle of the circle, sort of fling you out. But that force doesn't actually exist. It's an apparent force. Now, the centripetal force can come from different places. It can come from tension on a string when you're twirling something around. It could be the normal force on a track, like on a roller coaster. It can be gravity for planetary motion. The centripetal force comes from lots of different places. Even friction on tires when a car goes around a corner. There's lots of places centripetal force can come from. But it always, always, always points to the center of the circle. So a really common diagram you'll often see for circular motion might look something like this, where you have a circle, and then what you can have is an object on it. So we'll put an object on it like this, moving in a circular path, and you can label your things that are going on. For example, your velocity. The velocity vector is tangent to the circle, and the force would be something like this, pointing to the middle of the circle. So this is a pretty common diagram you'll see for circular motion. Now it's really important that those two vectors, the velocity vector and the force vector, are perpendicular to each other. Because since those two vectors are perpendicular to each other, we've got the velocity vector is perpendicular to the force vector. Because those two are perpendicular, all it can do is change direction. That's all it can do. Okay? If the force was parallel to the velocity a little bit, it could cause it to speed up or slow down. But since they're perpendicular, all it can do is change the direction. Now, this is a form of acceleration. This actually is an acceleration. More specifically, it's called centripetal acceleration. And most people, when they think about acceleration, they think about going faster and slower. But acceleration just means the velocity changes. And it could be a speed up, it could be a slow down, but in this case, it's strictly a change in direction, so it's still called an acceleration. Now, from other derivations, centripetal acceleration can be found by doing v squared over r. Now, centripetal force is just a force, which means it follows Newton's laws. So if we want to calculate centripetal force and we apply Newton's second law to it, centripetal force would just be MAC. If we replace the AC with the v squared over r, you get the very familiar expression of mv squared over r. And of course, this mv squared over r, as mentioned before, comes from lots of places. It can be from tension, it can come from the force of friction, it could be Fn, it could be the force of gravity. There's lots of places that force can come from, causing things to move in a circular pathway.